Alright, so welcome everybody. Today I want to share my experience on integrating Kotlin Multiplatform into an existing project. And with this talk I want to share the process that we have followed to introduce it, and the failure, the struggles, but also the success. So, I'll introduce myself quickly. I'm Marco Gomoerio, I'm based in Venice and I work remotely for Uniware, that is a Berlin-based startup that is working to reinvent how emails works in college. And my background is Android first, but during the years I also learned iOS development and I've done some cross-platform stuff with React Native and Flutter, mostly with Flutter, fortunately for me. And these are my handles if you want to follow me on the web. Alright, let's start with the story. And in this story, there is Alice, that is a mobile developer, and she's working on a newsreader app. And in that app, there is a feature that uses this simple data class. But there is a problem, and things are not working as expected. And Alice realized that the problem is related to the fact that the author field seems to be nullable and it should not be. So she decided to ask to Bob, that is the backend developer, what's going on. But Bob says that the author field is not nullable. But of course things are not working, so Bob decides to give a deeper look, and guess what? There was a problem in the backend, and the author is nullable. Okay, I have another story, and this time there is Charlie, that is a product manager, and Charlie asks to Alice to start working on a new iOS feature, and this feature is the same that Alice has already developed on Android. And for Alice, this is not a problem because she is a mobile developer and she knows both the platform. But she realized that apart from the UI code, she's just translating Kotlin into Swift, and this is a boring task to do. Okay, and now I bet that at least one of the two episodes already happened to you in your career. Maybe the first one, because the second one is more related to startup and to small teams. But I've told you these two episodes because they have a common theme. And this theme is execution speed. And in fact, both small and large teams don't have an infinite amount of time to develop a feature. So it will be wonderful if we can reduce the time that we spend to develop the same feature on different platforms. And of course, it also will be wonderful if we can reduce the time that we spend to fix some nasty bugs that, for example, are introduced in a boring piece of code to write, because boring code leads to error. Of course, this is a law. And how to solve and to tackle these issues? We can go with a classic cross-platform solution, like, for example, React Native or Flutter. And for example, back in the days at Uniware, we have decided to develop a new feature with React Native and then introduce that feature into our existing native application. And that was not a good idea, to be honest, because we had some performance issue, especially on Android. And of course, this is a project-specific problem, but the main problem with this cross-platform solution is the fact that they are trying to unify the UI declaration between different platforms. And to unify different platforms, we need to make some compromises, because different platforms have different patterns, have different architecture, different history, different choices and different foundations. So to unify them, we need to make a compromise. And sometimes these compromises are not so beautiful and so successful to make. And to solve this issue, we can use Kotlin Multiplatform. Um, and that's because Kotlin Multiplatform is not about compiling all the code for all the platform, but only a subset of it. And this subset is all the code that is not UI related. Because UI is complicated to unify, and so we can share non-UI code. And this UI code can be, for example, the entire business logic, or only the network layer, or only the data layer, or, for example, some utility methods that we use in our project. Okay, so it seemed beautiful to go, but how to approach? Well, in most of the cases, you are starting from an existing project. So you already have an infrastructure, an architecture, some repository, and so on. And plus, usually you don't have time to do a big rewrite of your entire project. So for example, you don't have the time to move to a monorepo structure like the one you see in the Kotlin Multiplatform mobile example on the web. And you can do it also, for example, because there could be management constraints on it. So, for example, the backend is developed by an external team, and you can't easily unify all in a single repo. But fortunately, to solve this issue, in software development, we can use some piece of code that someone else wrote, or even ourselves wrote, and we can import that piece of code as a library in our project. So, in our specific case, we can choose a little piece of tech stack to start with. We can move it to a Kotlin Multiplatform library, and we can integrate that in our specific project. But where to start? Well, we can start from boring code that is boring to write multiple times. So in this way, we can reduce the amount of error, because if we write it only once, we have only one possibility to make some mistakes. Or we can go with features and code that centralize the source of truth. So, for example, if a field is nullable or not, or if or for some constants, and so on. Because if we have a single source of truth, we have also a single point of failure. So, a single place to find the error. Or finally, we can start from that features or codes that can be gradually extracted, because, and this is important, because at this stage we don't know yet if Kotlin Multiplatform is the right solution for us. And so if we spend, for example, a huge amount of time to move the entire network layer, and we don't know if is the right solution, we will end to a huge amount of time wasted. And so if we start from something that can be gradually extracted, we can start by little, validate our idea, and then go bigger with other piece of the code. So the real example of that description can be the DTOs, or can be some common models that you are using inside the app, or some utility methods that every project has. And at Univer, we have decided to go and to start from the DTOs. And now you understand why I've told you before the first story. All right. Now that we have a common ground, let's start building something. And all the code that you will see in the presentation is extracted from a project that I wrote and that I published on my GitHub. so you can go and check it out. And this project is composed by a backend written with Ktor, and that exposes an endpoint that returns a list of news from Hacker News. And then there is an Android client and an iOS client to read that news. And finally, there is a library named HN Foundation that is a Kotlin Multiplatform library that contains the DTOs that are used by the Android clients and by the backend. So let's start building this library, and let's start by creating the project. And we can do it with the wizard provided by IntelliJ that has been really improved with the 1.4 release of Kotlin. And basically with this, in the wizard, we have to choose a Kotlin Multiplatform mobile library, and the wizard will create for us the Android and iOS target. So next we need to add the JVM target, of course, if we need it. And I prefer to have the JVM separated from the Android target, because if I need something Android specific, everything is already set it up. So now we have to decide how to publish our library, and in this case I've decided to go with Maven. So I've used the Maven Publish plugin for Gradle. And that's it about DevOps stuff. So now we are ready to write some code in our library, and all we need to do is write this simple DTO, that is the DTO that will be used for returning the news. So now we can publish our library in the Maven repository, but for this specific example, I've decided to publish it in a local repository, because it was overkill to create a Maven repository just for this sample. Okay, and now that we have developed our library, it's time to integrate it into the Android and the backend project. So let's start from Android, and first of all we need to define the dependency in the build.gradle file, and next we can use it and return a list of news DTO inside our network code. And that's it, basically. Of course, if you want to have a look to the entire code, you can go to the GitHub repository. For the backend, instead, first of all, we need to define the dependency. And next, with Ktor, we can easily expose an endpoint to return our news. And that's it. We have finally an Android app and a backend that shares some code. And what about iOS? Well, on iOS things are harder, but let's see why. First of all, some common information. And on iOS, the equivalent of the JAR and the AAR is the framework. And the framework can be distributed with different dependency manager solutions. We can use CocoaPods, we can use Carthage, we can use the Swift package manager. And all the code that we write in Kotlin Multiplatform is compiled into a framework, and that framework will be used by our iOS application. And this packing task is performed by a task, sorry for the repetition, and this task is created automatically for us when we create a new Kotlin Multiplatform project. And this task is called by Xcode automatically when we hit the run button. And there are some variables that are computed at runtime by Xcode. and are based on the situation that on which we are hitting the run button. And these variables are these three. And the first one is the configuration. So if we are building a framework for debug purposes, or if we are building a framework for production. And next, the other field is the architecture that we need. So if we are building for the simulator, we will need the x64 architecture. And if we are building for the real devices, we will need an ARM64 architecture. And as I said before, these fields are automatically inferred by the situation, by the current situation. So we can't use this task to create a framework that will be used by external application because we don't know a priori these fields. So this was a close path for me. So I decided to give a look to another solution, and I've started to look into the CocoaPod plugin for developed by JetBrains. That is basically a plugin that creates a CocoaPod repository that contains the framework. And this repository exposes a script that can be called by Xcode to build the framework. And again, there are two beautiful fields that are computed at runtime. So another closed path for us. So how to do it? Well, after some research, I've discovered that there are the FAT framework. And a FAT framework is a framework that contains all the different architectures that we want. So this is the right solution for us. So fortunately, there is a Gradle task that we can use to create a framework, and so I created two different tasks that uses the task that I just show you. And basically, these two tasks creates a framework for debug and for release. All we need to do is to provide the architecture that we want and the configuration that we want. In this case, debug. And of course, if we for the other task that creates a release framework, we will need to write release instead of debug. And next, we have to define also a destination for the framework. And in this case, the destination will be a CocoaPod repository that basically is a Git repository that contains, of course, the framework, the debug symbol, and a pod spec. And the pod spec is a file that defines how the CocoaPod repository looks like. So, for example, it contains the name of the library, the version number, the repository, where to find it, and so on. And I'm not going deep into the definition of a CocoaPod repository, because there is a very well made tutorial on how to achieve it. And I leave you the link if you are interested. And the only thing that I'm going to say is the fact that the repository can be private or public depending on your needs. So now that we have finally a CocoaPod repository with our framework, we can define the dependency in the iOS project. So in this case, I'm using the CocoaPod solution. So I need to write something in the pod file, and in this line I say that I want the iChain Foundation library that is contained in this Git repository, and you can find it in the develop branch. In this case, I specified a branch because for developing a feature, I don't want to use every time a new version number. So I can iterate fast, but of course for the production release, I specify a tag, so I'm sure what version and what code I'm using. All right, so we need to build the framework, we need to pack it, we need to put in a CocoaPod repository, we need to update the version, we need to commit, publish, bing, boom, bam, lots of boring stuff to do. So there is room for a script because I'm lazy. And of course, I created a task that does all these things for me. So there is a task for building a developer framework, a debug framework, and a release framework. And they are pretty much the same, but with some differences that I will show you. All right, for the debug framework, first of all, I use the develop branch of the CocoaPod repository. Next, I build the framework. And after building the framework, I update the version code on the podspec file. And then I commit all the changes to the CocoaPod repository. And basically that's it. For the release framework, instead, I'm using the master branch, and the only difference is that I'm tagging the commit to specify a version that the iOS app can use. And that's it for the DevOps stuff. Yes, there are a little big work to do, but we can do it. So now we can move to the actual application, and there are other problems. And this time the problems are regarding the serialization, because on iOS it's not as simple as on Android. In fact, on Android, for example, if we are using the JSON library, for example, and the field of the data class that are the same of the fields in the JSON file, we don't have to do anything, and all is working out of the box. On iOS, instead, no. And on iOS, for example, for the network request, you are using a Llama file, that is the equivalent of retrofit. And for the serialization, you are using the Codable protocol from Apple or other solution like Object Mapper. And there are other solutions because Apple didn't came first with the Codable support, but and the community did some extra work to cover that all. And for example, at Univer we are using Object Mapper for legacy reason, basically. And to deserialize an object, you have to comply to the decodable or the mappable protocol, if you are using Codable or the Object Mapper. And the protocol is basically the same of an interface on the JVM board. Again, I'm not going deep into the Codable and Object Mapper arguments, but I leave for you some reference if you are interested, so you can give a deeper look. And so let's start by complying to the Codable protocol. So we need to define a new class on Swift that inherits from our Kotlin Multiplatform use DTO and implements the decodable protocol. So what we need to do at the end is to create a secondary constructor that initializes the news DTO fields with some default values. And then we need to initialize all the different fields with the value from the JSON. But as you may already have noticed, we can do this right now. Because first of all, our news DTO is a data class, and we can inherit from it. Secondly, all the fields are immutable, so we can't modify it. And third thing, that is not a problem, let's say, is that we don't have an empty constructor. And this is not a problem because, of course, we can define here in Swift some default values by using the primary constructor. But I don't like to do it because I like to have a single source of truth in one place. So in this case, in Kotlin Multiplatform, with all the default values in Kotlin Multiplatform. So let's move to Kotlin Multiplatform and to modify the news DTO. So we have to switch from data class to open class, and we have to switch to var from val, and we have to define an empty constructor. And in this way, we can now go back to Swift and use our network request and deserialize our object. So after that, we can run our application and spam in our face a beautiful exception, and you are going to see multiple times this exception if you are using Kotlin Multiplatform and multi-threading, because you can't share object between different threads. And in this case, we are making the network request on a background thread, and then we are accessing the objects, the result, in this background thread, and this is not allowed. And because with the Kotlin native, we can't share an object between different threads if this object is not immutable. And that because Kotlin native have a different concurrency model that will change in the future, but right now here it is. And I'm not explaining how it works because I will need another talk, but I suggest you to give a look to this talk by Kevin Galligan from the Kotlin Conf that is very interesting, and you can find it on YouTube. Or you can give a look to the blog post that Kevin wrote. And both of these resources are very good resources to start with and to understand the Kotlin native concurrency model. But in just 2 words, to share an object between different threads, we need to make it immutable. And we can make it immutable by frozen it. And to freeze it, we can use a method that is provided by Kotlin native. But I suggest you to use the stately library from TouchLab that exposes a freeze method also in the common target. So if the code is executed on Android, it doesn't do anything because we don't need to freeze object on the JVM. Otherwise, if the code is executed on iOS or in any native target, the method will do what it needs to do. So in this case, we have to move back again to Kotlin Multiplatform to add the support for the freeze method. And now, after the initialization of the fields on our secondary constructor on the news DTO decodable, we have to freeze the object, and in this way we can share it between different threads. Alright, so finally we have a working iOS application as well. And this was a tough journey, I know. And we have faced lots of difficulties, but unfortunately we a bit of sweat and blood we have resolved it. And let's summarize a bit with these difficulties. And the first one was how to organize the project without a monorepo structure. And this task was difficult because there, in the on the web there weren't any kind of example with without a monorepo structure, but only with monorepo. And for us, a monorepo structure is not the right solution. And so before having a working solution, I had to do a lot of research, but fortunately I was able to solve this issue, and this is one of the reasons that I've decided to make this talk, because after a lot of sweat, I wanted to give back to the community. And another issue and another difficulty was Gradle, because there are always difficulties with Gradle. But besides jokes, I was not a Gradle superhero before, and I'm not now. But for the I'm for defining the different tasks and the different structure, you will need a lot of Gradle knowledge. And I can assure you that after starting working with Kotlin Multiplatform, you will increase your Gradle knowledge. And another issue that is related to the first one is how to distribute effectively the iOS framework. And this again was not an easy task, because all the solutions that I found on the web are coupled to the monorepo structure. So, for example, the pack for Xcode task that we have seen before, and the CocoaPods plugin. So I needed to do a lot of research and about how frameworks works, and it was not so easy to do, to be honest. Being able to create a fat framework was a huge success, at least for me. And finally, the problem was that is more project specific, but I wanted to show you is how to handle the serialization on iOS, and also this task was very difficult, and it required lots of research and try and fail, but we succeed to do it. And so after all these problems and all these solutions, I've extracted a pattern that I suggest you to follow if you want to start using Kotlin Multiplatform. And these frameworks says that you have to start little and then go bigger. Because first of all, you need to validate your idea and to validate if a Kotlin Multiplatform is the right solution for you. So during this process, you will spend a huge amount of time to deal with, let's call it DevOps things. So how to distribute, how to publish, and to how to consume the library in your existing project. So if you have to do all of this huge work, and at the same time you have to move a huge part of the code of your old code to Kotlin Multiplatform, you will spend a huge amount of time. And if this trial fails, you have waste a lot of time. So if you start little, you can validate the process, and when you have validated the process, you can go bigger and share lots of features. For example, at Uniware, after succeeding with the DTOs sharing, we decided to share also the entire data layer, and so we started using SQLite to write the SQL queries once and to share the data layer. and we are pretty happy about that solution. All right, so I leave some reference that I've used to build this talk, and also to if you want to know more about the argument that I've touched. And basically that's it. Thank you for your attention. Again, these are my handles if you want to follow me. And of course, if you have any kind of question that you can reach me out and ask me answer to the question that you have asked me during the event. Ask if to use in production, because right now is in alpha, and I have already said we are using it in production at Uniware, and it aren't any issue that I think that you can use it. But you have to take in mind that since it's in alpha, maybe something cannot work, or maybe there is some bugs that let you waste a bit more time. For example, for structuring, I can say for maybe in the Gradle part or in the structure part. So take in mind this, and also maybe you will spend more time investigating, because since it is still in alpha, maybe there is a huge amount of resources like the one like for a stable product for 4 years. But don't worry, because there is a lot of documentation, and if you go to the Kotlin Multiplatform mobile website portal that is online recently, there are lots of resources to start with. Next questions. Do you think that in the future we can use Kotlin Multiplatform to do UI with Compose and Swift UI? And another related question is, do you think in the future something like Compose will work with Kotlin Multiplatform and provide the UI for it? Yes, I think so. And also because JetBrains is working and he set up a team to work with Compose. So I don't know if in the Swift with in the iOS Compose will work also on iOS side. This is my secret dream, but in my opinion, we will be able to use Compose for building at least native application or desktop application. Yes. All right. Another question. We implement separate UIs with cross-platform frameworks like Flutter. Do you still believe EMP would be a better choice? Can I use Flutter to do UI stuff? I think that you can create application with Kotlin Multiplatform below and upper layer Flutter. I think that it will be a mess to handle dependency, but with the tool. But I think that you can do it, and maybe I've seen it in the web or in an article, in a sample. I don't know, but I will not do it. I will choose or Flutter or Kotlin Multiplatform. And respect to the first one, I think that are different solutions for to choose. I will go with Flutter for and other cross-platform solution for MVPs. So if you have to validate your idea, or for example for a short span application, like for an event, a conference, something like that. And instead, if you need more complicated solution, some scalable solution and difficult things to do, I will go with native, I guess, um, because it works better, I think, and maybe with a shared layer of Kotlin Multiplatform. And these are different choice to go with. Of course, depends on the it really depends on the project, but these are kind of my view. And I've also written a blog post about these differences and what I think about it, and you can find it on the last slide of reference. All right, another question. Is there a dependency injection framework you can share between Android and iOS currently? Yes, you can use Coin or Coding. I've used Coin in a side project that use Kotlin Multiplatform, and I'm happy with it. So you can check it out both. There is very good documentation about it. All right, another one. You mentioned in your story that the backend and frontend have to agree on property nullability. What about always assuming nullability in your DTOs? That was you have a more robust app. Okay, these are opinions, of course. I think that if a field is not null, and for example, because in the database is set as not null, uh, there is not any it's not a good idea to put it nullable, because if can't be null in any way, put it nullable, it only creates confusion, in my opinion. So if you agree on some on the nullability, and if you agree on what fields are nullable and not, there will be not any problem, in my opinion, and this is the solution and the structure that I will follow, and I follow. All right, another question. There is a new plugin for Android Studio to create Kotlin multi-platform mobile application. You can build iOS app directly to Android Studio. Yes, and I've used it in my pet project. And but this is a different scope. You can use it if you have. If you have a monorepo structure, so you have all the Android iOS application in the same repo. In the case that I've described in this talk, so in a non-monorepo, in a multi-repo project, you can't use that module because the iOS application will be called outside, and this is a different. It's a different, of course, situation, and that's it. But the new plugin is very useful, and I love it for when I'm dealing with a monorepo project. Okay, what about using shared DB and networking libs? It is supported. Are there any plans to do so? If not, no, it's supported. And for databases, you can use SQLite. That is the same solution. That is a solution very well made, and we are using it at Univer, and we are pretty happy with it. So we can use it. So you can use it. And for networking, there is Ktor, that is the same Ktor that I used for the backend, because Ktor is a library that provides network capabilities both for server and clients. So you can use it. And final question, that is not a question, but a suggestion, and that there is a nice KMP library list on GitHub, and I suggest you to give a look if you are looking for for a specific library. So that's it. Thank you very much for the attention. If you have any other question, you can reach me out on Twitter. Thank you.